everyone, welcome to another episode of The Shot with Cosmos, and cheers to Jupey Jupes!
Jupey Jupes!
Hey.
Well, that was an unsuccessful thing that just happened to me, but we will... Ooh, I was trying to hold my headphones on, did not go well. Anyway, Jupey Jupes. I know, it's all over my face.
All right. Show goes on.
Jupiter, the
Jupey
largest
Jupes.
planet in our solar system.
Yes.
He's named after the Roman version of Zeus, the king of the Greek gods, Jupiter. And now Zeus is known to be kind of a little rapey. In all the mythology. But for Rome, Jupiter personified divine authority of Rome.
Okay.
But what's interesting is the name of Jupiter, even though, people have been able to see it for as long as we've had eyes in the sky, maybe not always knowing what it was, but the name of Jupiter wasn't actually made official by the International Astronomical Union until 1976.
Oh, okay.
That's recent.
I know, that's very
recent.
recent. So that's like when Jupiter officially, they're like, all right, well, officially, this will be this planet's name now, since we've been using it for so long.
Jesus, really?
Did anyone ask
crazy to
Jupiter
think
if that's
about.
if that's what he wanted?
Well, no, of course not. Of course not. We don't really pay attention to the feelings of these planets out there. But okay, so observation of Jupiter, like written observation of Jupiter, goes back to Babylonian astronomers.
Mm-hmm.
All right, and also ancient Chinese astronomers have observed Jupiter, and there's documents of those as well. And it's the fourth brightest object in the sky, right? So it stands out. So if you're in a civilization without any light pollution all around, then it's going to be a noticeable feature that is moving amongst the stars in the sky.
Yeah, combined with the movement.
Yeah, exactly. So the planets themselves, which the Greeks called planetes, just means wandering stars. So for a long time, Jupiter was a member of these wandering stars, not really knowing exactly, necessarily what it is. Other than a star that moves. So our first, of course, actual view of Jupiter and what it looks like comes from Galileo Galilei when he looked through telescope in 1610 and observed Jupiter and observed that it had 4 moons with it. So in 1610 we got our first view of it. And of course, telescopes just keep getting better and better. We've developed spacecrafts that could go out and fly by Jupiter. And so we've been able to learn a lot about what this planet is. And I think most people know Jupiter being the largest planet in the solar system, right? That it's a big gas giant out there. It has something called a great red spot, which, is red.
It's great as well.
And I think that kind of is like the main basis of knowledge for Jupiter. As far as that, it's very surface, so to speak. Jupiter doesn't have a surface. That's why that's a little funny. Anyway, but we'll get to that. All right. So Jupiter is the 5th planet from the sun. It is 484 million miles from the sun, or 5.2 astronomical units, 1 AU being the distance the Earth is from the sun, 93 million miles. 1 year on Jupiter is 12 Earth years long.
Oh.
And 1 day...
Not 3.
Yeah.
Congratulations.
You get younger the further you go out.
Yeah.
1 day, though, is 10 Earth hours.
Yeah.
It's been so fast. It's been so fast.
It is the fastest spinning planet in the solar system. And it spins so fast, and actually most of the gas giants and the sun as well experience this, but they're wider at the equator than they are at the pole, so they get kind of flattened due to the speed of that rotation.
Like tossing a pizza.
Yeah. Like a vase.
No, oblates.
Oblates.
Yeah.
Oblates.
And like
Yeah.
a vase.
and like a vase. It's an oblate vase.
Hey.
And it has only a 3-degree tilt.
Okay.
Whereas ours is 24 and a half.
That's interesting.
22 and a half, I think. 23 and a half.
Whatever,
something like
around there. Okay, so it experienced actually like less seasonal change or less swing of the seasons.
Less variation.
Since it rotates on its axis almost straight up, right? Again, it's the largest planet in the solar system. It's 11 times wider than the Earth is, and it weighs more than twice all the other planets combined, which is still less than 0.1% of the sun's mass.
The sun. Yep.
All right, so, well, it's a big boy. It's still a little boy. Still a guy. All right.
But it has a Napoleon complex.
It has a Napoleon complex, yeah. Now, when Galileo first observed Jupiter through the telescope, there were 4 moons. It's the largest moons: Io, Ganymede, Callisto, and Europa. But as we've gotten better technology, we've been able to find more and more moons, and Jupiter has 95 moons.
That's a lot.
95 moons.
In my mind, if Galileo learned that, he would say, "No, there are 4 moons."
95 moons. And a lot of them are like these really tiny, just little rocks, like really tiny, like particles, that are hard to see, are darker material. And so we've needed better technology to be able to find them, to discover them. And also, with the moons, it has rings. Saturn being most famous for its rings, but all the gas giants, it turns out, have rings. And we couldn't even see Jupiter's rings until Voyager 1 flew past Jupiter, and Jupiter was backlit against the sunlight, and you could see just this arc of a ring around it. And it was like, oh, well, that's cool. And it's like small dark particles that they think are basically or meteoroids that are slamming into the innermost moons, and those pieces of the moons are breaking off and feeding that ring system around Jupiter. It's badass. It's a badass ball of gas, is what it is. Now, Jupiter being a gas giant, it's primarily made of hydrogen and helium, and it's not like a cloud that you can just fly through.
No.
Things get denser and hotter the deeper into Jupiter you go. In fact, things get so squeezed together that hydrogen turns to liquid. So you get this like liquid layer, and then things get so squished down that like the electrons get squeezed off, and you get this like electrically conducive liquid hydrogen layer. And because of the fast rotation combined with that, it has this huge magnetic field that is generated.
Right, because electrical charges, so electrons in motion will generate a magnetic field.
Yeah.
If they're spinning and stuff. So.
Yeah, so that's what, and it's huge. It's 14 times stronger than the Earth.
14?
14 times stronger than our magnetic field, and it balloons out to 600,000 to 2 million miles towards the sun, and then it has a tail that extends more than 600 million miles behind Jupes.
Wow.
That's like as far as Saturn is.
It's even further.
That's it's at 600 million miles.
Yeah.
Yeah.
So Saturn's about 500 million from the sun.
So it goes into Saturn's area. So it has magnificent aurora because of this magnetic field, and it's all these charged particles that get trapped, but also like huge amount of radiation for the innermost moons. And that's an issue also with sending spacecrafts too close to Jupiter, because that high amount of radiation can interfere with that technology. But going down further into Jupiter, you do eventually, most likely, possibly, we don't know for sure, we're still learning with the Juno spacecraft that's orbiting Jupiter, but it either has a solid core or a core that is like super hot and dense, like, and soupy, of iron primarily, and other silicates similar to quartz. All right, but we're learning more about that currently with the Juno spacecraft. Now, what we see on Jupiter is its uppermost atmospheric layers of that gas. And there's 3 distinct cloud layers that are about 44 miles thick. And the top cloud is ammonia ice. Then the middle is kind of like this ammonium hydrosulfide crystal layer. I don't know what that means, but it sounds like you don't want to breathe it.
No.
And then below that, the lowermost air, or the innermost layer, is water ice and vapor.
Oh, that's nice.
I know.
Okay.
So a nice little reprieve from the poisons.
From death.
Death
I
poisons.
mean, you just drowned there,
I guess
though.
so.
You know, with the water vapor and.
Now, the famous features that we see are the different, the red and white kind of bands going around Jupiter, these belts and zones. And they're these like strong east wind, west winds that are moving in opposite directions.
Okay.
And the jet streams for these can reach as deep as 2,000 miles.
Wow.
Which is pretty cool. And of course, the most noticeable feature on Jupiter is the Great Red Spot. This is a huge storm, a hurricane-like storm in its atmosphere. It's been observed for more than 300 years, but it is shrinking. So in the past, you could fit like 3 Earths across it, and now it's a little over 1 Earth could fit across it.
Okay.
So it is
It's
shrinking
kinda
as, I
smaller.
guess, the energy of a storm, dissipates over time. But Jupiter's so huge, and these storms are so huge that they can last. They have so much energy that they can last
Centuries.
centuries, essentially. And it goes to a depth of about 300 miles below the cloud tops, and speeds are about 300 miles per hour.
So you're looking into the
You're
atmosphere.
looking into the atmosphere
Nice.
there. So it's not a place you want to necessarily take a vacation to.
But it's beautiful.
But it is beautiful to look at from a
Especially with Juno.
distance. Yes, the Juno spacecraft has the best pictures of Jupiter.
Gorgeous.
And Jupiter is like the little star that couldn't, almost, of our solar system. If Jupiter had gotten a mere 70 times more massive, it would have been able to ignite nuclear fusion in its core and become a star.
And that would cause some problems for us.
It would definitely cause some problems for us, but it would be a binary star system, and most star systems are binary systems that we found out there.
So
in
our
space.
sun is rare.
It's
unique.
rare. It's rare. Jupiter
Well, I don't want to say unique. It's not unique, but it's rare.
Yeah. Jupiter is
It's special.
It just couldn't get enough mass. But you know what? Jupiter will always be the star of our hearts.
Oh.
So cheers to Jupiter,
Jupey Jupes.
a.k.a. Jupey Jupes. We love you, and we'll see you at night. Cheers, everyone. Thanks for watching.
Cheers.
Follow us on all
Bye.
the things. Cosmos. Adios.